Now, when your BBC Micro arrived, I would imagine that the first thing that you did was to read through the welcome booklet that came with it. And having read through that, I expect you played all the programs on the welcome cassette. And these will have given you a fair idea of just what the machine is capable of. Now, since then, you may have bought other programs, games perhaps, or business programs. But sooner or later, you're going to want to write your own programs to do something that you're interested in. Now, obviously, I can't tell you what to write programs about. That will depend on you. But what I can do during the next hour or so is set you on the right road as regards designing programs and writing them in BASIC. Now, before we start looking at the individual statements that make up the BASIC language, I think it'll be useful if we spend just a couple of minutes looking at the inside of the machine to see what goes on in there. And the best way to do that, I think, will be on a piece of paper. Now, inside your machine is a large area of memory. Memory in which information is stored. Now, some of this is available for you to use, and some of it is already full. Let's divide it up like this. In part of the memory, there is what we call the machine operating system. And this is a series of instructions whose job it is to control the machine, to control your television display, to control your cassette recorder. Now, we also have what's called the basic interpreter. And this is a program whose job it is to understand the basic statements that you write, to make sure that they are correct, and then to execute them. And then in the rest of this storage, we have your program. If we write your program here, and remember, these are the statements that you will write. We'll also require an area called the screen memory. And into this part of the memory will go all the information that needs to be shown on the television screen. Now, we don't have to be concerned too much at the moment about what's happening in the machine operating system and what's happening in the basic interpreter. What we're going to be doing is writing the basic statements to go into the program area of the memory. And those basic statements will, among other things, make things appear on the screen. Now, let's look in a little more detail at what happens inside that program area. Now, your program will be written as a series of lines of coding, as a series of statements. And every one of those statements is going to be numbered. For example, we might number them 10, 20, 30, 40. You'll see in a moment why I haven't numbered them 1, 2, 3, 4, but why I've left gaps between those numbers. Now, these numbers are very important, because it's only by looking at these numbers that the basic interpreter knows in which order these statements are to be used. Here we've got number 10 before number 20, before number 30, before number 40. Well, that's the theory. Now let's look to see what that's like on the screen. What you can see here is the first 6 lines of a much larger program. The program is at the moment sitting in the computer's memory, and I've asked it just to list the first 6 lines. And you can see the line numbers I was talking about, 10, 20, 30, 40, 50, and 60, at the beginning of each line. Now, the way I asked the computer to list the program is by using a list command. Down here on the left-hand side, you can see the flashing cursor, and you can see a little arrowhead. When you see these two together, it means the computer is ready to accept a command. And the command I used was a list command, simply L-I-S-T, List by itself would ask the computer to print out the whole program on the screen. Watch. As soon as I pressed the return key to show the end of the command, every line in the program was printed on the screen, and there were far too many of them to be seen on the screen at the same time, and so the ones I was interested in were lost from the top of the screen. If I only want to list a few of the lines in my program, then I have to use a slightly more complicated list statement. List followed by the first line, 10, a comma, and the last line, 60. This command says, list out my program starting at line 10 and finishing at line 60. Now, when I press return at the end of the command, I get exactly those lines printed out and no others. Now, the way they are at the moment, it's slightly difficult to read because there's no space between the line number and the line of BASIC. I can ask the computer to insert an extra space each time it lists out my program by using another command, a listo command. Listo 7. Right. Now, after I've pressed return, we still have the flashing cursor and the little arrowhead to tell me it's ready for another command. But if I list again, I should get some extra spaces put into my listing. Let's try it. List 10 to 60, and you see we now have a column of spaces following the line number. Now these line numbers, I said, are used by BASIC to decide in which order the lines in your program should occur. And we use these line numbers when we want to insert a new line, or change a line, or delete a line from our program. For example, suppose we want to insert a new line of coding between line 10 and line 20. All we need to do is think of a number between 10 and 20. Let's say 15. So we type in a command starting with the line number. Let's suppose the command will be print. Don't worry too much about what each of these commands does, because we'll be going through them in later parts of this video session. Now, when I've entered that line that says 15 print, this new line has been inserted into my program between 10 and 20. And if I list 10 to 60 again, we should see it in the right place. List 10 to 60. And as you see, line 15 has been put correctly between 10 and 20. If we want to delete a line, then all we have to do is type its line number. Let's suppose I want to delete line 10. By simply typing 10 and then return, I've removed line 10 from the program. List again. And it's gone. And if we want to replace a line of coding with another line, then we can simply type in the new version of the line. Let's suppose we want to replace line 50. We simply need to start with the line number, 50, and then type in whatever text we want to be in the line. This new line 50 has now replaced the old line 50 in our program. We can list again to confirm that it in fact has happened. As you see, the old line 50 has gone, and we have our new one. Now that's all very well if we want to replace a line completely with brand new coding. But if we had to retype every line in which we'd made a typing mistake, we'd have an awful lot of typing to do. And so when we've only got a small change to make in a line, we use the editing keys, which you see on the right-hand side of your keyboard. Now let's see what happens when we use these arrow keys. If we push the up arrow key once, you'll see that two things happen. Firstly, the flashing cursor has moved up one line, and the space where it was has been replaced by a square white block. If we continue to push it up, that flashing cursor line moves up a line each time. Similarly, with the down arrow key, pushing it once moves it down one line, and it continues to move down the more we push it. The right arrow key and the left arrow key move the cursor left and right. Notice that these keys, like all the other keys on the keyboard, repeat automatically after half a second. Hold the key down, and the cursor automatically goes to the right. Notice that it returns on the next line down. Similarly, if we continue to go up, when it gets to the top of the screen, it comes back to the bottom. Now, what's the use of this movable cursor? Well, let's suppose we wanted to change line 20. Instead of saying 20 repeat, suppose we wanted to say 20 please repeat. Down here, the very bottom right-hand corner of the keyboard, is a key marked copy. And this does exactly that. When we press it, the character that was under the flashing cursor is copied to the line where our typing input normally goes. Every time we press copy, one character is copied. As it stands, we've now copied the whole of line 20 to a new line. If we pressed return then and listed the program, of course you'd find that there was no difference. We've simply replaced line 20 with an identical line 20. But if we reposition that copy cursor to the 20 again, press the copy key twice, we can then type new information in. We wanted to say please. The new information that we've typed goes onto this line as normal. The copy cursor remains where it was. And now, if we press the copy key again, it will continue to copy the old line 20. Pressing return enters this as a new line 20. And if we list the program again, we see that the old line 20 has been replaced by our new changed version. Of course, this isn't basic. This is rubbish, which is a very important point, that when we're typing in lines of BASIC, they don't have to be valid. We can type in anything, English, French, or gibberish, because it's not checked to see if it's valid BASIC until we try to use it as a program. So we've seen the use of the copy key. The one next to it is marked delete, and that can be used to delete the character we've just typed. Let's suppose we were typing in a new line. Let's suppose it was line 17, and we were going to say, don't drop litter. But now we see we've made a spelling mistake. Instead of saying drop, we've said D-R-O-O. Every time we press the delete key, the last character entered is deleted. So we can delete back to where we made the mistake and then continue typing. Similarly, because the delete and copy keys are next to each other, it makes it very easy to change a wrong letter. For example, let's suppose we were going to change line 40. Instead of saying proc, we wanted to say prog. We've now copied the C from here to here, but we don't want the C in our final answer. Pressing the delete key once deletes the C from here. We can now type in the letter we wanted, G, and continue to copy. So the combination of delete and copy allows us to edit the text that we're typing along this line. The cursor keys allow us to move around the text that we've already typed to copy parts of it that we're going to need again. What we've looked at in this first part of the videotape are the basic principles of putting a program into the computer, making sure the lines are numbered, and editing the program to make changes to it, inserting new lines and deleting lines. Now, at the end of this part of the course, as with all of them, the first thing you should do is look in your user guide at the things we've discussed, because here you'll find them all described in full. And the other thing you want to do is practice what we've talked about. So in order to give you a chance to practice putting lines of coding in and modifying them, stop the tape now. When we come back, we'll start work on our first complete program. Now, there are many different types of program that you could write, from simple question and answer programs up to arcade games where you spend all your time killing aliens or perhaps digging holes for monsters to fall into. And some of the techniques used in writing these programs will differ according to the type of program. But the majority of the techniques are the same. We're going to start by writing a simple question and answer program that does some calculations. We're going to write a program that, given the length of a box, its depth, and its height, will calculate the capacity of the box, its volume, and the total surface area, but without a lid. Now, if that's what the program is going to do, it's going to have 4 basic stages. The first stage is going to be to show the questions that we want the user to answer. The second stage is to accept his answers that he types in from the keyboard. The third stage will be to do the calculations on the numbers he's typed in. And then when we've done the calculations and we have the answers, then the fourth stage will be to show the results back to the user. Now, there's one facility that BBC Basic has, which is very important when you're dividing your program up into separate sections. And every well-designed program is divided up like this. And this is the facility of procedures. Now, in BBC Basic, a procedure is a separate section of coding to perform a separate job within the program. The very first line of a procedure defines the procedure. Def proc name. Define the procedure, and then when I have name in small letters, you can put the name of your procedure, whatever you decide to call it. At the end of the procedure, we have a line that says end proc, and this tells BASIC that's the end of the procedure. And when we want to use the procedure, when we want our program to perform the work that the procedure does, we use a proc statement. We say proc followed by the name we gave the procedure. Now, that may seem a bit abstract, so let's look at a particular example. Now, let's suppose that during our program, at a certain point, we want to clear the screen completely and put page heading at the top. Now, we could write the coding to do that into a procedure called proc title. And line 50 in our program, to use that procedure, would simply say proc title. Somewhere else in the program, we would define that procedure. There's our def proc statement, and there's our end proc statement. The 2 lines of coding within that procedure are the work that's to be done whenever we use the line proc title. In this case, we have 2 basic statements, CLS, which clears the screen, and a print statement, which prints out the 2 words, page, heading. Now, once we've defined that procedure, we can use it from anywhere we like in the program. For example, at line 170, we might have another reference to proc title. Again, as soon as our program reached this point, we'd come here and execute these two statements again. So finally, let's have a look to see what proc title does. Well, it clears the screen and prints page heading at the top. Now, our program has 4 separate stages in it. We ask the user the questions, we take in his answers, we do the calculations, and then we show him the results. So we'll have 4 procedures in our program. Let's look at the first few lines of the coding. Here we have 7 lines of BASIC. 4 of those lines are proc statements, the ones we were discussing a moment ago. So let's just look at these first 3 lines. Line 10 starts REM, which stands for a remark. Now this isn't really part of the program. The BASIC interpreter won't try to do anything with a line like this, but it's a very useful way of putting into your program a comment that'll help you to understand it, or maybe help somebody else to understand it. I've put in a remark that says, a box program. Secondly, I've set a mode. Now the BBC computer can run in several different modes. These affect the number of characters you can get onto a line, the number of colors, the number of lines there are on the screen. I've said this program is going to run in mode 4, which means we'll have 40 characters across the screen and 32 lines vertically. Remember, mode 4 will work on any size of BBC computer. The next line, 30, doesn't do anything. That colon you see there is the character that BASIC uses to separate one statement from another. But on this line we have no statements. It's very useful, however, to have that on a line because it allows us to separate the different parts of the program. It makes it easier for us to see what part starts where and where it finishes. So our 4 procedures: proc questions, proc answers, proc calculate, and proc results. Well, that's defined the logic of our program as a series of 4 procedures. And now we can go ahead and write the coding for each of those separate procedures. And let's start with proc questions. Remember, this is the one that's going to display for the user the description of the information he has to enter. And so that's going to contain a series of print statements. Here you see the coding for it. Def proc questions and end proc to define the beginning and end of the procedure. And in between, 3 print statements. Very simple statements. We've asked to print the height of the box, the length of the box, and the depth of the box, describing the 3 items of information we want him to type in. Note these quotation marks at the beginning and the end of everything we want to print. These will always be the same, so these are constant values with quotation marks around them. Well, that's proc questions. Now let's look at proc answers. Now printing that information out is fairly straightforward because it's going to be the same information every time. It's constant information. But when we come on to looking at the values that the user of the program is going to type in, now those are going to be different every time. So we can't use constants. What we have to do is use what BASIC refers to as variables. Perhaps it'll be simplest if we look at the coding for proc answers, and you'll see what I mean. Here's our def proc statement and our end proc statement. The 3 statements within this procedure are all input statements. Input statements which will ask the user to type something in. What he types in is going to be put into height for the first number, length for the second number, and depth for the third number. Now height, length, and depth are names that we've thought up to describe these values that the user is going to put in. When the BASIC interpreter finds this input statement, input height, it doesn't recognize the word height as being a word in the BASIC language. So it allocates a piece of memory to store a number in, and it calls that piece of memory height. Now after we've used the word height, here in an input statement, whenever we refer to it again later, the basic interpreter knows that we want to look at the number that's in that piece of memory called height. So as the result of these three input statements, we've asked the basic interpreter to set up three areas of memory, one called height, one called length, one called depth. And the three numbers that the user is going to type in will be placed in those areas of memory. And we'll be able to use them later as part of our calculations. Well, we have our three numbers in, and so the next thing to do is the calculation. And we're doing that in Proc Calculate. So let's have a look at the coding for that to see how it works. Now, if we list the program, first thing we see is the fact that it's now too big to go onto the screen. Lines 10 to 30 have gone off the top of the screen, and we're left with just 40 down to 270. Now, as our programs get bigger and bigger, this is going to be more of a problem. So perhaps this is a good time to introduce the idea of putting the screen into paged mode. And we do that by using a key we haven't used yet, the Control key. Now, the Control key is rather unusual because it only works in conjunction with other keys. If we use it by itself, it has no effect at all. Now, we're going to use it in conjunction with the N key. We're going to type Control N. We hold down the Control key and type N. It's most important that you hold the Control key down while you type N. The screen is now in paged mode, which means that it won't allow the listing to fly off the top of the screen without giving you a chance to see what it says. Let's prove that by listing the program again. As you can see, we still have the beginning of the program at the top of the screen, but at the bottom, we haven't listed to the end of the program. Now, you can tell when the computer is waiting to show the rest of the listing because these two lights are on, the caps lock and the shift lock lights. And the way that you tell the computer that it can continue and show you the next page of the listing is by pressing the shift key. As you can see, it's now continued the listing to the end of the program. So Control N puts the screen into paged mode, and you'll find that Control O takes it out of paged mode again and leaves it as it was before. There are several other control codes that you can use to obtain different effects, and there's a full list of them in your user guide. However, let's go back to our calculations. Here's Proc Calculate, with the def proc statement at the beginning and the end proc at the end. Now you'll recognize these names, length, depth, and height. These were the variables where we put the numbers that our user typed in. However, these names here are new ones: base, side, end, volume, area. That's another 5 variables that we're asking BASIC to define as part of our calculation. It'll take the value that's in length, multiply it by the value that's in depth. That asterisk is used in BASIC to mean multiply. And it'll put the answer in a piece of storage which it will call base. Similarly, multiplying length and height puts the answer into side, depth and height into end. This now calculates the volume of the complete box, multiplying the length by the depth by the height, and the area consists of 2 sides, 2 ends, and a base. Plus signs to indicate addition. And although I've put brackets around these calculations to make it look a lot clearer, they're not actually necessary. It would have done the calculation the same way even without the brackets. Notice that I've used lowercase letters for all these variable names. You don't have to. BASIC does allow you to use uppercase or lowercase letters. But I think it's a good idea because it does allow you to see very easily which words in your program are your variable names and which are the basic keywords, which must be in uppercase. Okay, back to our program. We now have our two answers in volume and area. And the only thing that remains to be done is to print those answers, which we're going to do in Proc results. So we'll just see the rest of the program by listing from line 280 onwards. And there you see Proc results. Very simple, only two statements in the procedure. They're both print statements. We're printing out that the volume is, and then we're printing the volume that we calculated. The second print statement prints area is, and then prints the area that we calculated. Now, before we go to run this program, I think we should just do a final check of the logic to make sure we haven't forgotten anything. It's always worth doing a final check of the logic before you run the program, just in case there is something silly that you've left out. Here's the beginning of the program. We went into mode 4. We executed the procedure to ask the questions, the procedure to obtain the answers, the one to do the calculation, and the one to print the results. And then what? Well, our program will continue executing, and it'll carry on down here and try to execute proc questions again. Well, if we're going to make this a very simple program, we really should make it stop at this point, once it's done the job once. So we need to insert a new statement there, an end statement. Let's make it line 80. Remember, we can insert a new line simply by typing its number and then the text of the line. We can check that it's gone into the right place by listing that same set of lines again. And as you can see, we now have line 80 end. Well, only one thing remains to be done, and that's to run the program to see what it looks like. To run the program, RUN for run, and return. Here are the first three lines to be printed by our first procedure. And then we have a question mark followed by a cursor. This tells us that the computer is waiting for us to type in the first of those three numbers, the height of the box. Well, let's say that's 25. 25, and press return. Length of the box, let's say it's 30. And for the depth, let's put 40. Press return for the third time, and there are our results. From volume is, and the value for the volume, area is, and the value for the surface area. Our little arrowhead and the flashing cursor tell us that the program has finished. It's done the job once and terminated. Well, the program seems to work, though I don't think anybody would claim that the output looks very elegant or very pretty. But that we'll fix in the next session on this tape. However, we have created our first complete working program. Now, what we've done is to record that program on the soundtrack of this videotape following this little session. And at the same time, you'll see a diagram giving you instructions for how to copy the soundtrack from your videotape onto your own tape recorder, so that you can then load it into your program and play with the coding yourself. Well, that's the program as we left it at the end of the last session. It's not very impressive, but as I said, it does work. It does produce the answers we asked for. Now, our first job is going to be to tidy it up, to improve the quality of the output. Because if you're going to ask somebody to use one of your programs, then it's got to look right. They've got to look at the screen and they've got to want to use it. Now, compare the output from that version of the program with the output from this version. Well, as you can see, that's quite an improvement over our first version of the program. Various things have improved the appearance of the screen. For a start, the answers to the questions go in opposite the questions, so it's much easier to see which question and which answer relate to one another. The numbers that we type in and the numbers that are the result are printed in reverse, as black letters on a white background instead of white on black, and this makes them easier to distinguish. And then that final point, asking the user if he wants to do another calculation, giving him the chance to say yes or no. Well, that looked better. How do we achieve that in BASIC? Well, here are the first two procedures, Proc Questions and Proc Answers. If we look at the coding, we'll see some significant changes from the original version. On these three print statements, we now have the word tab followed by numbers in brackets. And on the three input statements, again we have tab followed by two numbers in brackets. Now tab, when used in a print statement or an input statement, allows us to position our coding to anywhere we like within the screen. Now if you remember, this was being done in mode 4. So we have 40 characters horizontally, and we have 32 lines vertically. Tab 5,3 means move to position 5 along the line on line 3. Semicolon means print this immediately following that position. So the second print statement, position 5 along the line, but on line 5, will cause depth of box to be printed 2 lines below length of box, but in the same position along the line. Similarly, 5,7 makes height of box be printed another 2 lines down. When we look at our input statements, the first one is tab 22,3. That's position 22 along the line on line 3. And you notice that line 3 occurs in both of these statements. On the print statement saying length of box, and on the input statement asking for the length, which means that length of box is printed here on the screen, and then the input statement positions the cursor immediately following that text for the user to type in his number. Similarly, when we input the depth, that's position 22 on line 5, which is the same line that we used to type depth of box. Similarly, the height is on line 7, on the same line as the text height of box. So that's the first difference. Using the tab in a print or input statement to be able to position you exactly on the screen. In mode 4, that's anywhere from position 0 at the very left of the screen up to position 39 at the very right-hand side of the screen. So that's the first difference. Now the second difference comes here in lines 200 and 240. In each of these two lines, we've put two color statements. Here, color 0, color 129, and here, color 1 and color 128. Now the color statement is used to change the color of the text that we're printing. In mode 4, color 0 means black and color 1 means white. So here we've said print in black. But of course our background is black, and if we printed black numbers on a black background, we wouldn't be able to see them. Color 129 changes the color of the background to color number 1. If the number you put in the color statement is bigger than 127, then BASIC assumes you mean the background color. Right? Color 128, as we've used here, means make the background color 0. Color 129 means make the background color 1. So while we're inputting our three numbers what we type at the keyboard appears on the screen in black letters on a white background. And as soon as we've finished typing in those three numbers, we switch back to using white letters on a black background. Right, so those are two of the changes, allowing us to position ourselves to a precise location on the screen and changing between white letters on a black background and black letters on a white background. Now, the other change that we made was in the control of the program, asking the user if he wanted to do another calculation. Now, there are two things about this extra part of the program. One is the fact that we need some way of persuading the program to repeat over and over again. And the second thing is that the user had to type in a letter, Y or N, instead of a number. So we're going to have to learn how to handle variables that won't hold numbers, but will hold strings of other characters. Let's look at the coding for the beginning of the program. It's basically the same as the original version, except for line 30, line 80, and line 90. Now, line 30 and line 90 go together. They form what's called a repeat until loop. And the effect of them is to ensure that this coding is repeated over and over again until something happens. Well, let's see what that something is. ANS $ equals N. Now, that's in small letters, so that's a variable name. But it's got a $ following it. And that $ is very important. This tells BASIC that ANS is not a variable that's going to hold a number. It's going to be a character variable. It's going to hold a string of characters. Where does it get a value from? Well, it comes from here. This input statement in 80, the tab we've just seen used, another Y or N. Now, if we put a string in quotation marks in an input statement, then BASIC will print it out for us before it tries to input the value. So what we said is move to position 515 on the screen, print out another Y or N, and then take the result, whatever the user typed in, as a string of characters and put it into ANS $. Now, we hope the user is only going to type one character, either a Y or an N. If it's a Y, we want to go back to the beginning and repeat proc questions, proc answers, proc calculate, and proc results. If it's an N, it means the user doesn't want to run the program again, and so we can continue to the end statement. That's exactly what this repeat until does. It repeats, it goes round and round, executing these again and again until the user has typed in an N into the variable ANS $. That becomes true. ANS $ is equal to N, at which point we can come through to the end statement and the program will finally finish. So that's a new sort of variable, a character variable. And the only way that BASIC can tell that a variable is for holding character strings is because of that $ on the end of it. If it doesn't have a $ on the end, then BASIC will expect to hold a number in that variable. So if you need to handle strings of characters, remember to put that $ on the end of your variable name. Now, we've seen input used to input a numeric value and a string value. But in fact, input isn't the only way of accepting information from the keyboard. Now, watch me run this program again and see if you can see the difference between this version and the last version. We type the digits of the first number, 13 perhaps, the second number, 45, pressing return after each, the third number, 6 perhaps, and press return. We're asked, do we want another? So we press Y, and immediately without waiting for us to press return, it's accepted the Y and gone to run the program again. So what's the difference? We didn't use an input statement that time, we used something else. If we look at the listing of the program, we'll see how that worked. The difference is that we've replaced the input statement by these two statements. Now, this print statement simply prints out the same message as before, another Y or N. This statement puts a value into ANS dollar, not by inputting it, but by giving it the value that get dollar provides. Now, get dollar is a function in BASIC. BASIC contains many functions to do many different things. Get does one thing. It waits for somebody to type a single key on the keyboard and then gives you that one character back. So as soon as we've printed that prompt, another Y or N, as soon as any key is pressed on the keyboard, the one character string corresponding to that key is placed in ANS dollar. So we don't have to press return. As soon as the user presses Y or N, that value goes into ANS dollar and can then be tested by this until following. Now, sometimes it's useful to save the user having to type return after every question if all the answers are going to be single letters, Y, N, U, D. And so in that sort of situation, using the get function and putting the value into a character variable can be more convenient than using an input statement. Now that's got the layout of the program right. It's got the format of the output to the user right. But after all, the BBC Micro is a color machine. It seems rather a shame to have it printing simple black and white letters. Can't we make the program work in color? Well, the answer is, of course, that we can. How about this? That's the color called magenta. Now, in order to see how we've managed to achieve that, we'll have to look back at the coding at the beginning of the program. There's the answer. In line 25, I've put a VDU statement. Right? Now, the VDU statement does many different things. And, of course, there's a list of them in your user guide. But VDU 19 is used to change colors. Now, we are in mode 4. Mode 4 is what's called a two-color mode. We can only have two colors on the screen at one time. And they're called color 0 and color 1. And we've already used them in our color statement. What this VDU statement does is to say, when I say color 1, what I really mean is color number 5. And looking again in your user guide, you'll find that color 5 is magenta. So until we do another mode change, or until the program terminates, everything that we print in color 1 will come out in color 5, which is magenta. Color 0 would be the background, and we can change the color of the background as well by inserting a new VDU statement. That particular combination is perhaps not one that I would choose, but you can pick any pair of colors you like out of the palette of 8 different ones. To get the green background there, we used this statement. There it is, statement 26, another VDU 19 statement, this time changing color 0, that's the normal background color, to color 2, which is that green. You'll notice that on both of these VDU 19 statements, I've got 3 zeros following the 2 color numbers. If you don't put those in, then your program won't work. Those 3 extra noughts are required by the format of a VDU 19, so don't try and cut corners by leaving them out. Well, we're going to take a break there at the end of this program so that you can copy the program from the soundtrack following this, onto your own tape recorder, as we did with the previous program. And while you're looking at it, make sure that you understand what each of those statements does. Look them up in the user guide and change the program yourself. Improve it. Make it do something different. And in the next part of this videotape, we'll look at graphics. Well, I said we were going to look at graphics in this session. And so the simplest way to start with graphics is to extend the program we've been using by getting it to draw what we've been talking about, like this. Now, this much you should be familiar with. But on entering the third number this time, we've got a nice perspective picture of the box. And in fact, that box will change its shape according to the numbers we put in. Let's put in one that isn't so long. Let's put in one that's only 100 long, 20 deep, and 50 high. Hardly worth calling a box at all. All right, how did we get that drawing done? And how did we make sure that the top half of the screen was used for text and the bottom half for the graphics? Well, we put 2 extra procedures into the program. Right, the things that are new in this coding are line 30 here, Proc Setup. That's a call to a different procedure, and note that it's outside the repeat until loop. So we'll only do that once at the beginning of the program. CLS you've seen for clear screen. CLG stands for clear graphics screen. We need that because our text and graphics are going to go into different parts of the screen. And down here at line 100, we are referring to a new procedure, Proc Drawbox. Well, let's take Proc Setup first to see what we need to do in the way of initialization in this program. Well, there's the procedure called Proc Setup, and it contains 2 new VDU calls, VDU 24 and VDU 28. Let's deal with VDU 28 first, because that's a little closer to what we've been working with. VDU 28 sets up what we call a text window. That says, only print text in part of the screen. Don't print it in the whole screen. These 4 numbers tell BASIC which part of the screen it's to use for text. The left-hand side means starting at column 0. 12 here means down to line 12. 39 means all the way across to column 39. And 0 means up to line 0. So those 4 numbers define the 4 sides of the text window. Now VDU 24 is used to define a graphics window. And that's the part of the screen in which we're going to draw graphics. Now, whereas with text, this top left-hand corner is thought of as position 0 on line 0, with graphics, the 0 position is right down at the bottom of the screen, at the bottom left. To specify a text position, for example, when we're using tab, we used column number and line number. When we specify graphics, we say the number of points to the right and the number of points up. And instead of being perhaps 40 characters by 32 characters, when we use graphics, the very left-hand position is 0, the right-hand position is 1279, the bottom is 0, and the top is 1023. So this VDU 24 statement says the graphics window should be 0 at the left. That's all the way to the left of the screen. 0 downwards, which means to the bottom of the screen. 1279, which means all the way to the right of the screen. But 512 up. So that's only halfway up the screen. So we've got a little less than half the screen for text and the bottom half of the screen for graphics. Color 129, color 0, simply says that for text we're going to use white background and black text printing on that background. Well, now we've got ourselves set up to do the drawing, let's look at the procedure which actually does it. Proc Drawbox. Now we've listed the program like this so that we can see the basic statements in part of the screen and the drawing they produced in the other part of the screen. If we go from the beginning of the procedure, we have clear graphics, which you've seen used before. The next 3 statements I'll skip over for the moment because they're involved in drawing this perspective back to the box. And we'll come down to line 550, which is the first statement that's directly concerned with the drawing. Now a move statement will move the graphics cursor to a particular point on the screen. In the same way that we used a text cursor to show where the next character should be printed, there's a graphics cursor that can be moved around to show where the next line should be drawn from. Move 0, 0 takes us to the very bottom left-hand corner of the graphics screen. The draw statement will draw a line from the current position of the cursor, remember that's down here, to the point described by these 2 numbers, length 0. Now length is the distance of the point from the left-hand side, and 0 is the distance up from the bottom. That's that point. This drawing was done with a length of 400, so this point is the point 400, 0. The second draw statement will draw another line. It won't start at the beginning again. It'll start where the last line finished. And that'll draw to the point identified by these 2 numbers, length, height. The length takes us this far in from the left of the screen, and height takes us this far up. So this second draw statement will draw a line from here, where the first draw statement finished, up to this corner. The third draw statement, draw a line to the point 0, height. That's the point 0, height. 0 meaning it's at the very left-hand side of the screen, and height meaning it's this far up from the bottom. And so we get this line drawn. And then the fourth draw statement, draw a line back to the same place that we started from, 0, 0. So that completes the 4th line of this front of the box. Now that's fairly straightforward, drawing a simple rectangle. It's a little more complicated to draw these sloping lines and the back of the box. And that's where this calculation came in. We need to use the depth of the box to decide how far back these lines are going to go. I've decided to use 30 degrees as this angle, and I've put 30 degrees converted to radians into the variable called angle. And up and right are the distance up from here to the back corner of the box, and right is the distance from here to the back side of the box. Let's look at this second sequence of move and draw statements. Move length 0. That moves to this point here. Remember the second corner of the box we drew. Move doesn't draw at all. It won't leave a line behind it. It simply moves the cursor to this point. The next statement, draw, draws to the point length plus right, well, that's length and that's right, followed by up, which is that distance. So it draws a diagonal line. The lines we draw don't have to be vertical or horizontal. They always go from the last place we visited to the point given in the draw statement. And if you follow the logic of these draw statements through, you'll find that we've drawn round the back of this box. If we can just move the listing on, so we can see the last two statements, those are the statements to draw this final line in to complete the box. Now, in this videotape, we've only had time to cover a few of the aspects of writing programs in BASIC on the BBC Micro. In future programs, we hope to be covering advanced graphics, sound, advanced string handling, and many of the other facilities that this machine has to offer. But for the moment, it's up to you to go away and to practice the things we've talked about during this tape. Till then, good programming.